Hi everyone, we are back and I want to go through a couple of these definitions for our ANOVA test, just to make sure that we know how to calculate them by hand in case we absolutely have to. So what we're going to do today is we're going to open up a new Mathematica notebook and I'm going to take in my ANOVA data, and actually I'm going to call it just DAT. So DAT is going to be, and I'm going to clear everything here. So I just want to make sure that we can compare, and if we have to, we can be able to calculate some of these values. So I'm going to read in our ANOVA table, or ANOVA data, and this is very helpful. Oops, where are you? I need your path. There we go. So this is going to be our data set, and it's going to go through the things. It's just thinking. All right, so the first thing I want to do, I see the yield is on the fourth column, fertilizers on the third column. So I want to calculate this Y bar, which is the overall sample mean. So I'm going to take all of my rows, my fourth column, and then I'm going to just take from the second row to the end of my list. And I'm going to take the mean of this, and this is going to be my overall sample mean of my yield, which is going to be our Y bar. So we've got the Y bar. Now let's calculate the sum of squares, which is going to be the sum from I, and here K is going to be our number of, basically, our variable is our yield. So actually, let's look at the data set, all three. Our data is fertilizer, or excuse me, our variable is fertilizer. Within there, we have three conditions. So K is going to be the number of conditions. So K here is going to be equal to 3. And we'll set that there. So I need to sum from 1 to K, and I'm going to take basically the average Y bar minus the average for each condition. So I'm going to have to take this data set, 2 to minus 1, and I'm going to find the position, like basically in this list, where does 1 occur? And I'll have these positions, and I'm going to extract from data all 4, 2 to minus 1. So I'm just basically saying all the positions where 1 occurs, give me my yield, the corresponding yield. So I'm just pulling out essentially that data set there. So that's the key, kind of idea here. So now I can take and actually calculate the mean of each of my Y sub i's. So that would be my Y sub I for the first condition. And I'm just going to loop this for here to I. And I'm going to make sure I from 1 to length of, I'm just going to do, there's 3 conditions. So this is my Y sub I, Y sub 2. So these are all my Y sub i's. So now I can do my Y sub I, the first one, minus my Y bar squared, times, now I actually have to do, I need to look at, instead of the mean here, and extracting each of this, I can actually find the number of each of the i's by looking at the length. So I want the length of each of these data sets. And luckily here they are all equal. So I gotta be careful, not Y sub I. N sub I. So there's my N sub I. And now I can do N sub I of 1 times this, good. And now I need to loop this again, and I need to do a sum. So I'm going to go from I from 1 to length of Ni, just to keep it general. And then I'm going to do total. And this should be the sum of the squares value. So 6.068, if we compare that, 6.068, 6.07, excellent. We've got that data set there. Fantastic. So what about the air sum of squares, or basically in this instance, the residual sum of squares? Well, we can calculate that too, except now we're going to have to look at 2 summations. So we're going to have to take each of our Y sub I, and we're going to have to actually extract. So for example, I'm going to take So we can look at this. So we extracted it for position 1. So now I'm going to have to minus this y sub I of 1. And I'm going to have to square that. So here and here. So we have to square that data set. And then I need to do this. I want to do a total of that. And then I need to do a table, because now we need to do that for each of the conditions. I, where I goes from 1 to length of yi. And then this, and then now I need to do a total of the other sum. So again, I'm going to take each of j, I'm going to look at condition 1, 1, and then look at each of the individual values for all of the, I keep saying, yeah, the one condition, and then I'm going to do it for all of my, well, it's the individual data points. But hopefully you get the picture. 35.88, what do we got? 35.8889, looks good to me. Fantastic. So we've got that as well. So we're able to calculate it. Air sum of squares, what's next? Hopefully, oops. Degrees of freedom. So we have 2 degrees of freedom. Our degrees of freedom is going to be k minus 1. So as we see here, so k minus 1 is 3 minus 1, which is going to give us 2. And the air sum, or the residual degrees of freedom, is going to just be this, n sub I, summing over those conditions k. So for r, we can look at this. If we do total of n sub I minus k, that's going to give us 93, which are degrees of freedom here. Excellent. Isn't it nice when everything kind of lines up together? Now, I can do the mean square. I can take my sum of squares of A. So I'm going to define this now. SSA. I'm going to call this ESSA. This is going to be my, actually, K minus, DFA equals K minus 1. EFA, air degrees of freedom. Okay, so if I do SSA divided by DFA, so 3.04, good. And if I take, finally, you can also do the F ratio, or actually I could probably also do the ESSA divided by EFA. Same thing here. And then the F ratio is just going to be my SSA divided by K minus 1 divided by ESSA divided by my big N is going to be the total of Ni. I should have defined that, minus K, which is the same thing. 7.86, that's my F value. And then now I'd have to look in the table. So again, we just want to show that we can do this for a one-way ANOVA. Now, would I want to do this? No, I don't want to do this, which is why we want to do our ANOVA analysis. But again, hopefully this puts all these variables in perspective and how you can do an ANOVA analysis by hand if you want to. And it's important, again, I may joke around, but it's important that we know what goes in that black box so we can determine if we did something wrong in our functions. So thanks, and I'll see you all next time. Bye.